The next stage of functionality we're going to be adding into our camera occlusion and collision system is a means by which to check the 4 points that we defined using our helper class, using the code that we put together in the previous video. Now, I have redrawn that diagram that we've been looking at for a few videos now, where we're taking our near clip plane on our view frustum, we're defining its 4 points, and we are running rays literally straight back from the location of the character's look at to each one of those points, as well as to a point back here behind the camera. We're performing all of these checks. And in this video, we're going to be handling a particular method called check camera points, whose job is literally to cycle through each one of these points and feed back some information. Literally, it's checking to see if we hit anything and how close was the object that we hit. Was there something in the way of each one of these ray casts?
Right.
So the way we're going to do this, kind of in general, is we're going to go line by line, or I'm sorry, point by point. Starting, now technically, it doesn't really matter which one we start with, but I think in the code we're going to start with upper left,
I believe so.
which from the angle of the camera would be this guy.
Right.
So we are going to cast out a ray straight out to this guy, and we're going to say, hey, did you hit something? In fact, before I even put my question mark, we're going to say, did you hit something other than the player?
Right.
Because let's not forget, the player has geometry, as we can see here, and that ray is coming from inside the character's head, and so we could end up with collision right there. Yeah, obviously, that would be problematic.
Yeah, we don't want that to happen.
So, did you hit something other than the player? If yes, get the distance, and make sure it looks more like an E, from the start of our line. So meaning how far away from this point was our impact. So if we were to have, you know, any kind of an object, and you can just picture anything. It could be a pole, it could be a wall, whatever you like. So that when we first do this check, blam, we hit something. The answer is, did you hit something other than the player? Yes, yes we did. What we would do is we would store this distance. Now, why is that distance important?
Well, we need that distance because we have a check to do. And what will happen is if it's realized it's hit something, its first instinct is to tell the camera to move forward.
Right.
And it's going to do it in several iterations. It's going to, hey, come a little bit closer. And it'll check again.
Right. I still can't see you. Come a little bit closer.
Yep, and it'll do that, but we can't do it forever.
Right.
So there's a limit to that. And what happens is if we've exceeded that limit of number of checks to do, it's going to tell the camera to jump to that nearest location plus a little factor.
Right. It's kind of like saying, look, you're taking too long.
Yep.
Just jump right here, right now.
Yep.
It's kind of like an emergency fallback, if you look at it that way. But there's more to it than that. We see, because we have all of these different points, if you wanted to be really technical, and I don't want to get too far fetched, but I don't think this is too bad. These 5 points define their own piece of three-dimensional geometry. It's a theoretical piece of geometry. It's not actually drawn on the screen. But you got to understand that at least the view frustum plane is a plane that exists in 3D space. You could have a complex object, something a lot more complex than a straight wall.
Well, a column is a good example.
A column's a great example because it's rounded. And if it could be blocking multiple points where some points are blocked deeper in than others.
Right.
And so we're going to be doing a couple of things here with that check. Because we're logging that distance, we can keep checking the rest of our points. We're not just going to check one. We're going to check all 5. And as we check each one, so we'll just start with upper left. And now, sorry for abbreviating that to UL. So did you hit somebody? Yes. Okay. Get the distance. Then let's check lower left. Again, the order in which doesn't really matter.
Right.
Did you hit somebody? Yes. Okay. I don't know what I was just trying to write there, but yes. Now, get his distance as well. Compare the two. Which of those 2 points, or which of those 2 points is collided by something that is closer?
Right.
Those two distances of the two distances where we hit something, which one is closer? Because that's going to be needed to help us figure out how far to bring the camera forward.
Right, because we don't want to partially bring the camera forward and have it positioned so it's still occluded. We want to make sure that all 5 of those points are checked, and we move that camera enough in space to free itself.
Right, and here's an example. If I kind of slide this stuff out of the way, at least temporarily, and then grab my brush. Now, let's look at the whole thing from a bird's eye view. So here's our character, and there's his eyes and his little nose, and here's a little point in space. Now, back here, we have our camera, and let's just say for sake of argument, here we have our near clip plane, and there's his points. Now there'd be 4, but it's all kind of stacked and perfectly lined up. So we've got our various rays that are being cast, and we got the one that goes back behind the camera, so we're staying nice and neat there. What happens when we have a complex piece of geometry that is at an angle? And let's keep it simple. I won't rotate it in 3D space for now, but what happens if it is...
Well, it's a wall at an angle. Right. There you go.
What if it's something like this? Then really we're blocking everything. So we know we need to update the camera, but we need to know how far forward to bring the camera, and that's going to be determined by figuring out which of these collisions took place the closest. So we have one that took place here, we have another one that took place back here. Which of these is the closest? Because we're going to need that to figure out how far forward to bring that camera. If we only bring it back to here, we're still colliding.
Mm-hmm.
So that's why we need to get all of these distances, and that's why we need to compare them.
Right.
We're just going to handle this with a series of if statements.
Yep.
If we collide, then store it, and then ask the next guy. If you collide, great, you've collided too. Check that against the last guy who collided. Is one lower or high? Is either one of these lower? Store the lower one.
Right. We're not getting the perfect distance for the camera, but we're getting the safest.
Something that helps.
Yep.
It really, and it's, yeah, that's a good point. We're not trying to get exactly that distance. We're just trying to get the value that makes the most sense to use as a calculation point.
Mm-hmm.
It's just a starting point from which we can derive where we need to move the camera.
Right.
Now, all that said, it all just kind of comes back to here. Did you hit something other than the player? If yes, get the distance from start, and then we're just going to do that for everybody, compare them all against each other, and see who came out the lowest.
Right.
That's all there is to it. The only other thing that this method is going to do, which is really more cool than anything else, is it's going to take all these invisible lines that we've been drawing as dotted lines, and it's going to make them real.
Yep. Inside your scene view, when you're running your game, you'll actually be able to see the rays, or the lines in this case, as they're being drawn out, which is a very good debugging tool when you're trying to figure all this stuff out.
It's tremendous, and it's going to be very helpful. Now, as just kind of a thing to throw out there, the lines that get drawn are not the actual rays.
Mm-hmm.
So if you see a line penetrating something, the actual drawn line doesn't mean anything.
Right. It's just a visual representation
of what's going on under the hood, and it's the collision of that ray that's going on under the hood that's important to you. So I want to make sure you understand that there is a difference between the ray that is cast and the ray that is actually drawn on the screen. They are two entirely different things.
Mm-hmm.
They're going to exist in the same spot, incidentally, but they are two separate systems. So again, that's all we're doing here. We're going to check each one of our points, make sure, see if they're colliding. If they are, we're going to grab whichever one collided the closest, and then we're going to draw all of our lines. Is there anything else we're going to do?
No, that's it for this method.
All right, so that's going to wrap up the theory discussion, and in the next video, we will code together this method. Thanks a lot for watching.